In this video, I'm going to go over two new rules. The first one is the biconditional elimination rule, and this one is pretty straightforward. The idea is that when you have a biconditional on one line and the A, whatever's at the beginning of the sentence, on another line, then you can, on a new line, put B. And then you would just notate that as double arrow elimination, and then the line that has the biconditional and the line that has, in this case, the A. Okay, it also works, however, to have on one line the biconditional, on another line to have whatever's at this position, the B, and then, but in that case, on this new line, we would put A. Works either way. So biconditional elimination is a pretty easy rule to use, but you need two lines to use it. Okay, next is the conditional introduction rule. And so the idea here is, well, first, still, if you have what's in green, then you can, on a new line, put what's in red. And so, since it's a conditional introduction rule, what we're putting on a new line will be a conditional. That said, this is a little more complicated. So a few things. First, in every proof that you've seen, there's been this vertical line, this guy here, running the length of the proof. The line numbers are to the left of it, and then the proof is on the right side of the line. Okay, now it may not have been obvious to you why we needed that line, but the idea is that there is this line, and as I said, it runs the length of the entire proof. Then sometimes we can create what we call a subproof, and the subproof will be along a line that's indented to the right. So this right here is a subproof. And to use the conditional introduction rule, we have to create a subproof. On the first line of the subproof, we can put whatever we want, and we notate it with AS for assumption, and whatever we put here will be the antecedent of our conditional. Okay, then we proceed with our proof as we normally would. When we get to whatever we want to be the consequent of the conditional, we stop. So in this case, that's going to be our B here. On the next line, we go back to the main line of our proof, and we write out the conditional. Okay, so again, the assumption that we made to begin the subproof is the antecedent. That is, it goes before the arrow in the conditional, and the last line of the subproof is the consequent, and so it goes after the arrow in our conditional. Putting a conditional on this line and back against the main line of our proof here closes the subproof, and then we can continue with the proof if we need to, or if this is the conclusion, then we would be done. All right, so of course we'll go through some examples. Okay, in this proof we're just going to use the biconditional elimination rule. So our premises are not E and Q, if and only if K. And then our second premise is K, and our conclusion is Q. Okay, so I've written out the two premises. Should have a line here. Okay, since I have, well, of course I have a biconditional on one line, and I have K here. K is on one side of the double arrow, so that means I can use the biconditional elimination rule, and on a new line put this. Okay, so double arrow elim lines 1 and 2. Okay, my conclusion is Q, so I just also need to do and elimination on line 3, and I'm done. Okay, next in this proof we have one premise, Q and R, and this is our conclusion, if S then R. Should have a line here. Okay, so since in our premise we just have Q and R, and our conclusion is going to be a conditional, we need to use the conditional introduction rule. So what we want to do is, on the next line, start a subproof. So 2, and the assumption that we're going to make to begin the subproof is going to be S, because that's the antecedent that we want in our conditional. Notate that with AS. Okay, and then I want the consequent to be R, so I want to get R, which is simple. I just need to use and elimination on line 1. Okay, and that's line 3. Okay, so in this case, that's all I need to do. I have my, of course, I have the antecedent, and I've I've gotten the consequent, so on the next line, I can put the conditional introduction, and I'm going to notate it as 2 through 3. That is the range. In this case, it's just 2 lines, but whatever it is, it's going to be the range of the entire subproof. Okay, so I'm done. I think there's an example like this one in the textbook in For All X, so you can kind of read the logic behind using the conditional introduction rule in this case. This is a pretty simple example. So I'm not going to talk about that. I will talk about it in this next example, though. So let's go to that. Okay, so here we have, again, just one premise, C or D, and our conclusion is a conditional, not D or C. Okay, so our next step is, again, going to be to start a subproof. And we want to start the subproof with not D. Okay, and what we want to get, of course, is C, because that's going to be our consequent. And we can do that because we have on this line, because we have on this line a disjunction. And on this line here, on line 2, we have the negation of one of the disjuncts. So not D, of course, is the negation of D. So that means using disjunction elimination, we can on this line put C. So that's wedge elim, lines 1 and 2. Okay, so again, it's not always going to be this way, but again, we just in 2 lines have gotten our conditional. So on the next line, back against the main line of the proof, we can put our conditional. Okay, so that's arrow I for introduction, and that's going to be, again, lines 2 through 3. Okay, so that's our conclusion, and we're done.